So what's a dim bulb tester actually for? The way I see it, there's two primary use cases: testing a mystery device for the very first time and retesting a device that you performed some sort of service to. Our first test subject is going to be an NAD 7100 receiver. And let's assume I know nothing about this unit. I picked it up at a garage sale. The original owner hasn't powered it on in 20 years. It's a complete mystery unit. So how do we test it? We're going to take the cord from our dim bulb tester and plug it straight into the wall. Next, we'll take the mystery device and plug it into the device under test socket. Now, before we power this on, let's review what's actually happening electronically with this tester. Now remember, this setup is super simple. In essence, we're just putting a light bulb filament in series with the hot connection to a device under test. Now, what happens when we power this device on? Current is going to start flowing in this circuit. And when current flows through a light bulb filament, it increases in temperature. As the temperature rises, so does the resistance, and that's what helps protect the device under test. So what we're going to see when we power this thing on is a bright flash on the bulb, and then it's going to come down. As the power supply charges, once everything stabilizes, it'll either have a dim glow or we won't really see anything at all. That's why we call it a dim bulb tester. That's all I'm going to go over on theory in this video. If you want to dive deeper on it, I have a completely different video called How a Dim Bulb Tester Actually Works. I'll leave a link in the description to that. You can also click on the on-screen card. All right, let's flip this thing on and see what happens. Nothing. And why is that? We need to make sure that the device under test is powered on first if we're going to flip this switch. Now, where's the power button? It's actually this right here. But if you look closely, you'll see a little tiny green light over here. And that's because this device has something called a standby transformer. This is what you get on units that have remote control power capability. There's a little circuit inside that just runs at low voltage until it gets a command either from the front panel or from the remote to turn on. Then it's going to switch in the main power supply. So let me just push this button and we'll see what happens. One more time. And there we go. Now, why did I have to do that twice? When we're coming from a cold situation where the main filter capacitors are completely discharged, they're going to draw heavy current at startup. We saw the bulb light bright, and that drops the voltage going to the device under test. And that voltage drop was enough to kill the power on relay. So I had to do it a second time, but this time the capacitors already had half of their charge and it was able to overcome it and turn on just fine. So if I demonstrate this again, I'm going to turn it off and I'm just going to let it sit for 3 or 4 seconds and we're going to turn it back on. We're not going to get as big of a flash as we did the first time, but it will still flash and it should power on. There we go. Wait for the relay click. And we're good to go. Let's take a close look at the bulb and you'll get a better idea of why it's called a dim bulb. Here's a close look at the filament inside of the bulb so you can see it's just barely glowing. That means there's a little bit of current flowing in this device, so the bulb doesn't have that much effect on the circuit right now. That example demonstrated the first primary use case for a dim bulb tester, and that's testing a mystery device for the very first time. So imagine that this device had some sort of catastrophic failure that we didn't know about. If we plugged it directly into the wall, it's going to have all the current capability that it needs to blow itself up. So when we put it behind a dim bulb tester, it gives us an opportunity to see if there's a major issue, and if there is an issue, it's going to limit the amount of damage that can be done. So that's the first use case, testing a mystery device. The second main use case for a dim bulb tester is retesting a device after you've performed some sort of service. And this has saved me hundreds of times in the past, even on simple servicing like replacing a relay, maybe swapping out a couple of caps, even cleaning controls. There's always opportunities to make mistakes. You could forget to solder in a wire, maybe you forgot to put a screw back in place that was establishing ground somewhere. Capacitor got put in backwards. The possibilities are endless. So having a dim bulb tester for a quick recheck after you've made a change is essential. So let's demonstrate that. Imagine I've been inside of this unit servicing it and I've messed something up and I messed it up bad. We've got it plugged into the dim bulb. Let's see what happens. The bulb lights up bright. The device is protected. No further damage is done. Now if I had taken that cable and plugged it directly into the wall, At a bare minimum, the fuse would have blown violently, but who knows what other damage could have taken place inside of the unit before the fuse blows. So that's why it's nice to use a dim bulb tester after you make any changes inside of a unit. With dim bulb testers, there's always going to be some gotchas. We already went over one example, which was the standby transformer in the NAD receiver. Another common one is soft start circuits in large amplifiers and monster receivers. If you choose a bulb that's too small, the device won't be able to start out properly. There's also devices that draw heavy current at idle, Class A amplifiers and certain vacuum tube power amplifiers. With these devices, you might not be able to select a bulb that's large enough to test it on dim bulb. There's also a handful of devices that shouldn't be tested on a dim bulb. A couple that come to mind are certain switch mode power supplies and VFET amplifiers. Now, one last thing. The dim bulb tester is highly effective at protecting the majority of devices, but in some cases, even if you've chosen the proper bulb, you can still do damage to the device under test. This isn't a silver bullet. Depending on the nature of the failure of the unit, there might be enough current available there to cause further damage, so just keep that in mind.